My bed buddy, yeah. All right, domain and range of linear functions is the topic. This is EOC number 8. Here we go. Let me see if I can line these cameras up so that it'll work. All right. Let's define some terms first, okay? Domain and range is something that we have all struggled with, pretty much. So let's define some terms. And this is on linear. This is not on quadratic. This is not on exponential. We've got the domain, which is the input values or value, which is also your x value or values. Okay? Then we have the range, which is output value or your y value or values. Sometimes it's a value, sometimes it is values. All right? We have different types of domains and ranges. We have something called discrete, which represents distinctive ordered pairs of data. Usually discrete is like in a chart. If it's on a graph, it would have dots. It would not have lines because you're not including everything in between. You are only including those distinct points. Okay? Continuous is another type of domain and range. I want to say type, I guess. It is another term we use to describe domain and range. Represents a function with or without restrictions. Oh, can't spell today. Okay, and usually like on a graph, that would be something with a line because you're including everything in between. Okay. All right, if you have an open circle around a point, that means that it does not include the value of this point. If you have a closed or a shaded circle, it does include the value of this point. And the only other thing we need to define here is we've answered what is the difference between continuous and discrete. So let's look at the last question at the bottom. It says, how do real-world situations affect the restrictions on the domain and range of linear functions? Real-world situations, so because it is possible that and I'm going to come up with real world situations. How about that? So we don't have to write it all out. Everybody remember RWS means real world situations. It is possible that in real world situations, some numbers may not be included. And an example of that would be such as height, such as negatives. If you're talking about height, you can't have a negative height, can you? Okay. If you're talking about width or length, you can't have a negative length or length. So in that situation, that would be such. So the domain of a linear function, our question to the beginning of this whole process here, what is the domain of this linear function? 1, 2, 3, because those are your x's. Okay? That was hard, right? Okay? All right, let's flip the page. We got lots of work. Yep. What? Texas. All right, because you don't have any x's yet.
No, I ain't got none.
All right. Which linear equation represents a line that passes through the point 3, 5 and has a y-intercept of -1?
Well, we can mark off A and C.
You think so?
I think we can.
Why is that?
It has to have a y-intercept of -1.
Because the y-intercept is not -1. All right, I agree with that. Okay, so now we just got to figure out the other two, right? How can we do that? Anybody have a clue? Okay, y equals mx plus b, and what do we know? We know that the y-intercept is -1, and we can solve for slopes. So we put in our point for our x and y value. Okay, if our point was x and y, 3 and 5, and solve for slopes. So I'm going to add 1 to both sides, and I end up with 3m is equal to 6. Divide both sides by 3, and m equals 2. So what is our answer? D.
And on B.
And why is B wrong?
Because it's negative and it's going down.
Yeah, but
It'd be going down from -1. It'd be going down 1 over 1, down 1 over 1.
that is correct. If you can visually see your graph in your head, not most of us are not that sophisticated to see that it would not include the 0.35. Okay, but if you are, then yes, that's definitely a way to look at it. So D is your answer. All right. So here's some forms of our equations that we know. Y equals mx plus b. What is that called? Slope-intercept form. Okay, we can manipulate that to find our slope. We could manipulate that to find our what? Y-intercept. All right. So if you have a slope at a point, you can find your y-intercept from this. If you have a y-intercept in a point, you can find your slope. So a very nice little equation that we use to help us out. What is this called? Standard form of a linear equation. Okay. Let's talk about the standard form of a linear equation. First off, both variables, meaning your x and y, are where? Are on the left side of your equation. Okay? A, B, and C are all integers. A must be positive. That is correct. So those are some things that we need to know about the standard form of an equation. Okay. All right. Last linear equation. What's this called? What? Look on your charts.
Our pink one?
Your pink ones. No, lots of people don't even have their charts.
Are you goofy? I have mine.
Point slope form.
I was getting around to it. That was what I was.
I wonder why it's called that. Because you have your slope and you have a point, a x1 and a y1, don't you? Okay? And this can be used to transform to the other various forms of linear functions. Now, we don't use it too often because we can use our y equals mx plus b pretty well. But if you had a point and a slope, you could solve for, if you had a point, you could solve for slope here. There's many things you can do, okay? How can the point slope be used to transform a linear function to slope-intercept form? Substitute, that's way down here. Substitute the point and the slope into the form and solve for y. And we did that. But like I said, most of the time we use the different. But if they gave me an equation in point slope form, I could identify my slope and a point with just looking at the equation. In other words, if they wrote the equation y minus 5 is equal to 3/4 times x minus 6, okay? And they said, what is a point on this line? What's my point?
Negative.
6,5. Not negative. If it had been negative, it would have changed these to positive, okay? So it's a point on my slope would be 6,5, and a point on my line would be 6,5, and so I could say a point is 6,5, and my slope is 3/4, couldn't I? Okay, so I could find my y-intercept by doing that, by plugging that information in back into y equals mx plus b. So these are all tools in your toolbox, people, that you have been building your algebra toolbox all year. All right, let's flip the page. What?
Still writing that thing. Let's see. No, that's correct. I got it.
All right. All right, flip the page. It says, which linear function best describes the graph below? Well, first thing I always identify is my b, which is what?
-4.
-4. So which ones can't it be?
D or B.
D or B. Next, I need to find my slope. What tool do I have in my toolbox to find my slope on a graph?
Rise over run.
Rise over run. Okay. And I could pick my y-intercept as one of those points. Another point I see is my x-intercept, actually. Now, I know it's going to be a positive or a negative slope.
Negative.
Negative slope. So I've got 1, 2, 3, 4 is my rise. My run is 1, 2, 3, 4, 5. So I've got y equals negative 4/5 x minus 4, and that matches what? A. Be careful. Okay. All right. What tool do I have in my toolbox to find slope from a table? What? No. There you go. Remember that your table, unless specified, is always x's and y's. Okay? So you have x and y values in this order unless they specify it differently.
What about if it's going like this?
Then if it's going like this, x's are on the top, y's are on the bottom. Okay, unless they specify it differently. So you always have, if you're finding slope from a table, what we call it is the change in y over the change in x, which is y2 minus y1 over x2 minus x1. Okay? How can tables be used? We just talked about it. What do? We call slope something. What is slope? Constant rate of change. So then use what? One of your points in y equals mx plus b to find b. And you're going to be doing that a lot on your assignment tonight. Okay? You find your slope. You use a point and your slope, and you plug it into y equals mx plus b to find your y-intercept, then you can find your equation. Okay? How can graphs? We just talked about it. Find y-intercept, and then use rise over run to find slope. What if you couldn't distinguish rise over run? Then what could you do? No.
You would have to make the...
Couldn't you pick any 2 points on the line? Yeah. And then use your change in y over your change of x. Okay? How can verbal descriptions be used to write linear equations? Y-intercept is your starting number. I say it's your one-time membership fee. It's whatever happens once, okay? Then your slope is your rate of change. It's always connected to your, like, per this, per that, or each, or every mile, or whatever it might be in a paragraph, okay? All right, so then let's look at our work for today. And we're going to do several together. And then we're going to take maybe a few off, if you're lucky.
Maybe we can work 3 of them together.
Maybe 3 of them?
Maybe 3 of them.
Maybe 3 of them. I don't know, Wesley. I might work more than 3. What do you think of that?
I like that idea.
You hope it's more than 3, and you hope I take some off.
I hope he stays.
You guys are just lucky that last year broke me, and they were like, we got to do all this, and I realized it was a lot, okay? All right, so let's do this. Let's look at page 110, okay? On page 110, right now, you may cross off number 8, okay? You may also, on page 111, cross off number 11.
111.
On 119, you may cross off 2. And on page 122, you can cross the whole page off.
Oh, yes.
Okay?
Brr.
So now let's go back and work a few together. All right? So let's go to page 110. And the hardest part of doing these is the graphs, finding domain and range. So the graph of the linear function y equals negative x plus 2 is shown below on the coordinate grid. What is the range of the function when the domain is greater than or equal to negative 2? All right, so we're looking at this graph. We need what is the range, right, which is the y value, when the domain, which is the x value, is greater than or equal to negative 2. All right, that's how I'm kind of writing my information down. So I got this nice little graph. I need to know what my y value is when my domain is greater than or equal to negative 2. Well, I could work on the graph. Or I could do this. I could do y is equal to negative, what did it tell me, negative 2? Plug that in for x plus 2, right? So now I know that y is going to be equal to 2 plus 2, which is 4. Oh, my goodness, that didn't give me a whole lot of information, did it?
No, ma'am.
No, it didn't. So where is my y at 4? Right here, isn't it? Okay. And my domain at negative 2 is over here, isn't it? Okay. So I know that my domain is right here. Okay. And I know that my range starts here. Does that make any sense? So where is that going to include? Is it going to be less than that? No, because I need it to be here over, but I need it to be here, and I need to have this be less than 4. So I've got to have it to where these two come together, and the plate, I've got 2, I've got 4, I'm going to go down, and in here is where I've got to be, because I have to be where this is included and this is included. Does that make any sense? If I was to go and put y is equal to, it said the domain is greater than or equal to negative 2. So what if I was to put a 4 in? Negative 4 plus 2. So y value would be what? Negative 2, right? So now I know that my y value could be a negative 2. So do you see how I'm picking points down here to know that it would have to be less than that line? So it's going to be C. Okay. 6 is easy. What is the domain of the function? So when the range is this, where am I going to plug the range in?
In your y equals.
Well, and that's my f of x, right? So if I take negative 2 is equal to negative 2x plus 6, I subtract 6 from both sides. I get negative 8 is equal to negative 2x. I'm sorry. And divide both sides by negative 2, I get x is equal to 4. Well, let's try the next one. Now I have a 2. So now 2 is equal to negative 2x plus 6. Subtract 6 from both sides. And I end up with negative 4 is equal to negative 2x. Divide by negative 2, and I end up with x is equal to 2. So far I have an x of 4 and an x of 2. I only see one answer choice that's going to work, but I'm going to plug the next one in. And this one says 2 is equal to, I'm sorry, this one says 4 is equal to negative 2x plus 6. So subtract 6 from both sides. And I end up with negative 2 is equal to negative 2x, divide by negative 2, and I end up with x is equal to 1. So my domain is 1, 2, and 4, which would be G. Okay?
I did it. I just entered in that y equals.
You are so smart, and then went to your table, huh? You are so smart, and that is a cheater way you could do that. That's right. What did Wesley? I don't have a calculator with me. Do you guys know what he's talking about? Yes or no?
Yep.
Okay. So, but just be careful whether they're asking for the y values or the x values, okay? That's what you have to be careful about. All right, and what, so all you did was y equals, and you put in negative 2x plus 6, went to second and table, and you said, okay, when my y value is negative 2, my x value is 4. When my y value is 2, x is 2. When my y value is 4, x is 1. Do you see? All right, D and C's now, because Big D wasn't sure what we were talking about. Okay. All right, the graph of the linear function y equals negative x plus 2 is shown below. Plus 4, I'm sorry. What is the domain of the function when the range is greater than or equal to 0? So what are you going to do? If I plug a y, 1 in for y, okay, I'm going to get what? Subtract 4 from both sides, I end up with negative 3 is equal to negative 2x, doesn't it? Okay, divide this, I'm going to end up with x is equal to positive 1.5. Doesn't tell me a whole lot, does it? What if I was to put 0 in? 0 is equal to negative 2x plus 4. Subtract 4 from both sides, I end up with negative 4 is equal to negative 2x. Divide by negative 2, I'd end up with x is equal to 2. That's as big as it can be. It's going what? It's going down, correct? Okay, so what do you think I need? Do you see YB is it? Now, if I was to come over here, I bet you could put in your calculator, since you guys like using your calculator so much. Negative 2x plus 4, hit second and table. And I'm looking at my values when my range is greater than or equal to 0. So my x could be 2, my x could be, hold on, yes, 1, my x could be 0. Do you see how I'm seeing this? Okay, so my domain has to be less than or equal to 2. Okay, we're not doing number 8. We crossed it off. We are going to go and do number 1 on page 115 together. Okay, I need to find my slope, don't I? It says, which of the following describes the line containing the points 2, 2? Okay, I need to find my slope. So I've got x1, y1, x2, y2. So I can do y2, which is what? Negative 4, subtract 2 over x2, which is negative 2, subtract 2. Negative 4 and negative 2 is negative 6. Negative 2 and negative 2 is negative 4. You simplify that, and I get what? 3 over 2 positive. Well, that wipes out A and C. Can this possibly be this point right here? Yes or no? Really? When I go and I plug in point negative 2, negative 4, okay, y minus a negative 4 is going to end up being what? A positive. Y plus 4. So it can't be this point. Okay? What about down here? I have positives, don't I? So y minus 2 is equal to 3/2 times x minus 2. Do you see that these two, when I pull them out, are positive 2, positive 2 as my point? Yes or no? Because remember, the formula is y1 minus, y minus y1. It doesn't, so you have to include this, and then whatever sign comes with the point. Okay, does that make sense to y'all? Okay, so my answer choice obviously is D there.
I entered it in my calculator again.
Did you?
I converted them over to y equals, and then I just looked.
And you could do that. You could convert them over to y equals and do that, okay? All right. For number 3, I'm just going to give you this. You need to find your slope. Then use 1 point and your slope in y equals mx plus b and solve. Ooh, I spelled solve wrong. And solve for b. And that is how you find your equation when you're given 2 points. Okay? When you're given your slope and a point, you do the same thing. You just you don't have to find your slope. You just go in and put your point and your slope in here, solve for your y-intercept. Okay? Number 4 is the killer. And the reason that it's the killer is because look at your equations. They're in standard form. Okay? So if I go ahead and solve for slope, step number 1, I'm going to do negative 4 minus 1 over negative 1 minus 3. Well, I'd really like you to wait if you could through this. Okay, and then I'm done. So you get negative 5 over what? Negative 4, which gives you 5 over 4 for your slope. So I know that my slope is 5 over 4. Now I need to solve for my b. So y equals mx plus b. I'm going to use a point. I'm going to use the second one. So negative 4 is equal to m, which is 5/4, times my x, which is negative 1, plus b, and I'm solving for b. Okay? All right. So this is going to be negative 4 is equal to negative 5/4 plus b. Add 5/4 to both sides. B is equal to, what is negative 4 plus 5/4? Put it in your calculator and tell me what it is. Negative 11 over 4. So now I know that my equation must be y equals 5/4 x minus 11 over 4. Now what do I have to do? I could either switch this to standard form, or I could go and do what over here? What could I do to all of these? Switch them to y equals. What do you think's easier? All right. So let's do that. Number 1, 4x minus 5y is equal to negative 7. Subtract 4x from both sides. I end up with negative 5y is equal to negative 4x minus 7. Divide everything by negative 5. I end up with y is equal to 4/5 x plus 7/5. Is that what I needed? No. So it's not going to be f, which tells me it's not going to be what? J. Okay. How many of you would guess G? How many would you guess H? Okay. If you guess G, do you see I had a negative here and a negative here, and I ended up with a positive here? Okay. My guess is it has to be H. 5x minus 4y is equal to 11. So then I would do subtract 5x from both sides. Minus 4y is equal to minus 5x plus 11. Divide by negative 4. I would end up with y is equal to 5/4 x minus 11/4. And that's what I needed, correct? Okay. And that would be H. You're not going to have any that you have to do that to. I did the one that was like that. Okay. All right. From a table we've talked about already. Like I said, use writer time to your advantage. Have a good day. You can go now.
Is the bell about to ring?